Okay, so today we are going to start putting together the two different parts of the applications that we worked on up to now. So you remember we first worked on the server side by implementing an API server, and then we worked on the client side where all the, say, information, all the logic was inside the client, but there was no communication with the server. Okay. Today we start putting them together and see what are the pieces that we are missing for putting them together. The first piece is how to enable React components to handle asynchronous behaviors or asynchronous events. Something that may happen in a way which is not directly controlled by React itself. And for this, we need to have a closer look at the life cycle of a component, so all the rendering phase and so on. So basically, a component in React is an object that is first created and mounted into the page. So the first phase called the mounting is when the component is first displayed in a given page. Okay, if you have one single component there and you are displaying that, rendering that in a page, the first display is a mount operation, where the object the instance corresponding to the component is created and initialized, for example, or the state variables are created in that moment and they are initialized in that moment. Then the component may update itself many times. Every time their props change, every time their state changes, the component re-renders, we say it, and we say this is an updating of an existing component. Then it may happen that in a following render, that component is no longer needed. So its father components don't render it anymore. And in that case, that component, that instance, is destroyed, is unmounted, so-called. And once unmounted, the component cannot be recovered in any way. If you are rendering again a same component in the same place, after unmounting it, you are actually mounting a new one, a new instance. Okay? This is the trick, if you remember, that we had to use for the behavior of the edit form, where we had a single form that was already there, and if we wanted to initialize again, we needed to tell React, please destroy this one and create a new one by using the key parameter, so that the old component was unmounted and the new one was mounted. Okay? So this is the normal life cycle of a component. And in these three different moments, different things happen. Normally, what we have is actually we call the function corresponding to the component, and it will return the rendering code. Okay, so the children component, the HTML, basically the DOM, the virtual DOM that we wanted to require. And this is the normal behavior. Now we are looking at how we can modify this behavior by introducing additional behavior that may depend on external factors. The key driver is that if I want a client to communicate with a server, that communication will be asynchronous. And so if I request some data, the data will arrive asynchronously. And will change some information which is outside the controlled data flow of React. Right now, we only had two types of variables. Local variables that get destroyed and recreated at every render, at every update, and states, which are strictly managed by React itself. Now we are going to have some other type of data that will change asynchronously. We already had some small form of asynchronous data changing, like user typing into forms, for example. These are some information that is, but as we saw, we immediately converted that into state changes with the on-click events. So what we are seeing that in the update phase, the state hook is used to recover the missing information, and the values of the properties and the values of the state are used during the so-called render phase. The render phase, I read in the sentence, is where the function behaves as a pure function. So during the render phase, nothing changes. Okay? No side effects happen. No data is changed. Only maybe local variables used, but they will be destroyed. Okay? And these are the place where React has full control over what happens, because a function can be called once, twice, many times, not called at all, remembering the last value. We know that the computation is always, from the same inputs, the result will always be the same. So React has full control over this phase. At the end of the render phase, here we have the virtual DOM. Okay, the tree of components that need to be rendered, and that we want to render, that we decided to render. And the next step is the commit phase, where React will take this rendering tree and updates the actual DOM in the browser. So this is automatic. And of course, it has a lot of side effects, because it's actually, in that case, the React library is modifying the browser data structures. So it has effects outside our function. Usually we don't care because this is automatic. No, this is done by React immediately. What we could do is that in this part, where there's no need of being purely functional, we can manage some sort of side effects. Okay, in this phase we can allow for something outside our pure functional behavior to happen. And in particular, there's the hook specialized in that, which is called useEffect. UseEffect is a hook for allowing us to process side effects. So applying something that has some effect outside the component, or receiving something, some information, some events, some data, that comes from outside the component. Information that doesn't come from props, information that doesn't come from states, maybe it comes from the network when I made a call. Okay? All of this is outside the pure functional behavior and should be managed in a separate moment. So React is always alternating between these two different states. Rendering, where everything is constant, and committing, where things may change, may happen. Okay? We are now learning how to create our own behaviors during the commit phase. For the moment, we didn't do anything here, or we only worked in the render phase. Side effects, what are they? Are any computation that affects something outside the scope of the function component. So something that when I execute will affect some variables outside, and the most important thing is, for example, reading data from a server. But to be precise, even a console.log statement is a side effect, because we are writing something to the console that is outside the function. It's some information, some data that goes outside the function. A pure function should only have all the information in the return statement. Console.log, we are using that for debug, okay, but technically we are creating a side effect. And in fact, we are seeing that maybe something is logged twice because React decides to render a component twice, and so on. So there are some strange behaviors because we are creating external effects on the render phase, which is controlled by React, that can decide to call a component one more time, and so on. Okay, But we can, we can manage that it's just for logging for debug purposes. But we cannot trust, for example, that behavior for logging user actions, for example. If you want to say to a database what the user is doing, we cannot allow a given action to be logged twice just because React renders the component twice. So in that case, we want to have control over the data that we are sending out. And actually, the rule is don't try to process any side effect in the body of the function component, so during the execution of the component itself, in the render phase. So in the render phase, no side effects. In the commit phase, we can use this hook that will run after the render phase is completed, after the DOM has been rendered into the browser, and then we can inject our own behavior. This behavior, of course, may have an effect over state variables, for example, that will then trigger a new render phase. So we are managing something outside React for reporting the data inside React itself. So everything lies on the definition of this new hook, which is called useEffect. And in theory, as I said, console.log should not be done. No, it creates a side effect. And the right way of doing that would be to put this statement inside a useEffect hook. So what useEffect does actually is take a function, a callback function, that will be executed during the commit phase. So we are executing that so after all the side effects, after all the rendering, all the DOM are being updated. Okay? So useEffect takes a function to execute outside the functional mode, and when we should say when this will be executed. Do we need it to be run at every render cycle, only at mount time, only at unmount time, at every refresh, and so on? So useEffect actually has two parameters, one function to execute, and one array that will specify how often we want to run this function. And then actually the function is executed, and we know that inside this function we don't have any, let's say, constraints over the type of computation we are doing. So the first parameter of useEffect is a function that may contain also side effects and anything else. For example, timers. If I'm setting a timer and then for example, for doing an animation, where you want to show something on a page and then make it disappear or make it appear later and so on, we can set up some timers that will make some state changes. Okay? All of these are, of course, outside the functional behavior, because the time goes on with no concern about the render cycles. It's something external. Okay? And we maybe make some examples on that. And then the second parameter is an array of dependencies. And according to how we define this, we have 4 different cases. Okay? What I say is that the API for useEffect is very, very dense, because it seems a very simple hook, but it has a lot of special cases in that. Okay? The idea is that the function, the callback function, will execute if at least one of the dependencies have changed between different successive renderings. Okay, so render, commit, and so on. UseEffect, after a render phase, will check this array, will check the values, or actually the variables that are listed inside this array, and we compare that value with the previous value from the previous render. If one of them changes, then the function will be executed. It will run the callback in the commit phase, before the next render. If more than one variable changes, the function is only executed once. Okay. After the render, I check the variables. Do I need to run the function or not? If there is some change, yes, otherwise not. The first time, of course, the variables will have a new value, so the hook will always run. And so it's a special case. So actually, this dependency array, the second argument, may have 3 different formats. I can omit, so it's undefined, no dependency array. If I don't provide any dependency array, then the callback is called after every rendering, at all renderings, every time. Second, so there are no dependencies, so I will run it always. Second case is an empty array, which is the total opposite. The hook will only run once, at the first render, at the mounting time. So when I mount the component for the first time, I'm scheduling the running of this hook, and then even if something changes, the hook will not be run again until the component is unmounted and mounted again, of course, because there will be a new instance. Okay, so at every render, or only at the first render, after the first render. Or in the middle, it will be if I provide a set of values that can be props, can be states, or can be simple expression or variables, local variables computed from props and state, because of course we can only use values from the React world, so properties and states, and which list the reasons why the hook should run. So if this property changes, then the hook needs to be run, and so on. Normally, the second case, so run only at mount time, is used for initializing data. So I'm running a page, a component, the component needs some external data, and will go and fetch this data. Then once the data is loaded, it will be loaded inside the state variable, and then the component may go on. In the second case, it's when the change of some data in a part of the page can trigger some behavior somewhere else, and so we need to monitor some data changes. Data changes that cannot be captured by the normal flow. So the format is like this. useEffect is a hook that doesn't return anything. There is no return value here. And it takes a callback with no arguments. There are no arguments in the callback, and it's just a function that will run at every rendering. And I'm saying every rendering because the second argument is missing. There's no second argument here. Or if the second argument is there and is empty, it will only run once. It's probably is the most common form of the hook. We need it for loading data when the component mounts. Or the other case where, of course, we have some state variables, some prop, and so on, and so we want to monitor that. So the difference is just in the second argument. Just beware, if we have this, it will also run the first time. At mount, so actually, when the component mounts, all the effects are always run. All the useEffects are run at least once at the beginning when the component is mounted. Then, according to the second argument, we decide when and whether they will be run again. Yeah, this is an example that shows two different hooks that are defined to run only at mount time or to run always, every time this number changes. So this number is a property. Imagine a button that will increase. There's a state, a counter. So every time I click, some number increases. And I discount component that receives this property, okay? Number. If the useEffect is only run at the beginning, it will actually take a snapshot of the initial value of the sum and will print only once. You see, my static number is 3, for example. And then you see that when the user clicks on this button, this sentence here, my static number, is not printed anymore. While in the second case, I have a statement that will print this value of the number, but will be called again every time this number changes. So every time the user will click on this button, the prop will change, of course. The component will render, of course, we know that. And then the hook will notice that one of the values on the dependency array have changed, and so we'll run again this hook and will print this message every time with an increasing value. Every time, just beware, it happens every time the value changes. So we need to ensure that the value actually changes. In this case, it's an increase. But if we are doing a set number to the same value as before, so in our mind, sometimes I say, okay, I'm changing this value by saying I'm assigning a new value to it. But if the new value is identical to the previous one, the hook is not run. It should be actually numerically different. Okay, so it's not a way of transferring an event from a component to another, because actually some data needs to change. It's monitoring the data. It's not monitoring the fact that it called the set number. So everything depends on the change. But of course, we need to make some real-world examples to see it better. How do effects and states interact with each other? Okay, so from one side, state variables can be, or properties, that normally a property comes from a state variable above, so actually a state variable can be in the dependencies of a hook, of an effect. Okay, so a change in the state may trigger an effect. And the other way around, inside the body of an effect, we can change some states. Actually, we can schedule the change of some states by calling a set function. And so actually the hook will schedule the state change, the state will change, and the component will be rendered again, and maybe the hook will be run again a second time if the same state that we are changing is in the dependency list. Let's make an example on our code, for example. So a simple one. So let's take our So I made a copy of the previous week's code in a folder client, and okay, I just modified a bit the appearance. I took the version where I have the list of all the questions, and I can toggle whether I want to see all the questions that have been asked or only my questions, this question asked by me, for example. And if going into detail, I see that and can go back and so on. So just the exercise of last week, a little bit polished, but it's the same. Okay. Imagine that we want to add some, welcome message here at the top. Some welcome message that will disappear after a couple of seconds. So when you go to the website, you see the message, and then it will go away. The simple things that we can imagine. So we need to render something conditionally. That's easy. We have a state variable that will tell us whether we want to render or not the message. That's easy. The problem is that this state variable will not change after some user action, so clicking on a button, but will change after some time has elapsed. And the elapsing of time creates events that go outside the cycle of the components. Okay? So that's a typical asynchronous effect. So what we could do is, for example, to add this message into the header, which is actually doing nothing. So in our components, I take the header, okay, and yeah, we can have maybe another container that will contain, so slash container, a message welcome to the application, or to the QI website, Q&A. Okay? So, no, it's displayed there. Sorry, I didn't want to display it there. Sorry, I need to put it outside the navbar, of course. Okay, so this is kind of a message that we want to show and then disappear. Okay? So we can make it conditional. And so I want to show it only if some variable is true. And welcome will be a state variable, of course. Okay, so we have const welcome is useState. We import useState, and initially will be true. Okay, so we are showing it. The trick is that we want this variable to become false after 2 seconds, for example. We need to call set welcome. Sorry, welcome. I'm missing the function. Set welcome. Set welcome to false after 2 seconds. But so we can set a timer for that, and in the callback of the timer we put the set welcome message. We cannot put create the timer here, for example, like that. Set timer (2 seconds), for example. Set timeout, sorry. Time out. Okay. What happened if I did this? Is that every time I'm in the render code here, in the render phase, so I'm doing something wrong because I'm creating an external resource, a timer, in the render phase, and so it's not according to the rules. Okay. Forget about the rules. What the practical issue is that we are creating an excessive number of timers. So for every time this component is re-rendered, is refreshed, maybe it's run twice by React, a new timer will be created. And they will trigger different times. Well, right now they are doing nothing bad because they're all doing the same. They're setting to false, this variable. So I'm setting the variable to false 20 times instead of just once. But if this hook should do something more, I'm doing something more in an uncontrolled way. I want to control that. I know that it has effects outside. It's not just the rendering. It's not a pure behavior. It's not something that can be repeated without any damage or any side effect. So we will put this. This is what we want to do. set a timer interval that after 2 seconds will set this variable to false, but we want to run it only once. So we put it inside a useEffect. We import useEffect, which takes a callback function, like this, a callback that contains this set timeout, and is only run at the beginning. So let me try to indent it better. So useEffect has 2 arguments. The first argument is a function. The second argument is the dependency array. This is only empty array, means I'm running only at mount time. What I am running at the mount time, I'm running this code, and this code will actually call the set timeout that will schedule the running of this other function. The hook and the timeout callback are executed in the render phase, in the commit phase, so outside the functional behavior. In this case, the timer callback will call a set state that will, of course, change this value, welcome, schedule the change of this value, and will trigger a render of the component. So if we do that, we should see, if I rerun the page, that this sentence is there and then disappears. And if I navigate through the website, since this component is always there, doesn't go away, the state is already false. I'm not displaying it again. The only way to display it again would be to destroy and recreate the component, in this case by refreshing the page and so restarting the application. If I had put this behavior into another component, every time the component is created, it will display the message and then disable it, so on. So it goes component by component. So with this mechanism, actually, how the automatic animations behave in a React application. Right now, it only depends on time. It's not a user event that you can manage with a on-click handler. It's something else that comes from outside. And in this case, it doesn't bring any data. Why is this dependency array empty, or where can it be empty? Well, it's simply because we only need to run this once. But why do we need to run it once? Because it doesn't depend on anything. So if we see this body here, it doesn't use any value of any property or any state variable. Okay? There are no props.something, and there is no state variables there. Okay? So there's nothing that could change, that could affect the behavior of this function. Normally, when we have something more complex to do, whenever inside the body of the effect we are using the value of some properties or some states, of course, using means reading, because we cannot change them, then normally those variables should be listed as dependencies. The simple rule is that every state or prop that we are reading inside the callback of an effect should be listed in the dependency array. Because actually, the callback depends on the value of those items. And if those items' value changes, I want to normally to re-execute the function. And this is what is writing here. Make sure that the array, the dependency array, includes all the values, props and state, that can change over time and that are used by effect. Otherwise, you have a misalignment between when the effect is running and when the values are changing. So there will be some value that change, that whose change is not reflected by the code. And usually we'll take to bugs, to parts of the page or parts of the application which are not updated enough, frequently enough. Every value referenced inside the effect should also appear in the dependency arrays, actually. Okay, so this, right now we cannot do anything more complex than this, basically because we have no source of asynchronous events rather than a timer. Okay. So I cannot invent anything meaningful with what we know. But the real reason why we are introducing effects is to do some communication with the server. Okay? So we need to understand, to know how to communicate with the server. What is the API for doing that? Just a comment before going to that is that this kind of effects sometimes can or could be used to update or to do some updates in the application state. So, for example, imagine you're here and you want to list the number of answers that we have here. Okay, so we have sometimes we want to add information here. Okay, question number 1, this is the question, there are 2 answers, and then I list the answers. So once we learn of course this number should change, so if I delete this, it should be updated and so on. So the idea could be, every time the list of answers changes, or actually the length of the list changes, I will update the count, which doesn't look by the idea. No? So let's try to implement them and then see. It means that we have some data here, then they want to show here, a number, that will be updated as a consequence of another value being updated, the length of the array. So I can monitor some state, and when this state changes, I will do something, for example, update another state. Okay? So we are inside the answer, and we want to render in the before the answer row, before that. Sorry, let me make it a bit larger. Answers display. Okay. Is this the? Sorry, let me find the. Yes, answer display. Okay, because the question is displayed before. Okay, in answer display. Okay, the idea is before the table we can put a message with the number of items. Okay. So, for example, let's wrap this into another component so that the table will be only one of the 2 children, and we put something like let's put just a paragraph for the moment. We have number answers. Okay, what is number is a state variable that we compute inside. So we have number, set number, as a use state, and correctly Copilot is telling me that we should give initial value to this use state from the length of the answers array that I receive as a prop. So this should work, probably. Yes, we have 2 answers there. Now, since it's a state, if I delete an answer, this number doesn't change until the state is recomputed. So the idea could be to have an effect that will monitor the length of the answers array. When its value changes, I can modify the number, set number, to, okay, the new length of the answers array. Yeah. No, yes. Remember that answers come from above, okay? So in this case, let me save it. We have 1 answer, of course, now, and if I add new answer, now we have 2. Now it should become easy to have a 3. And then I delete this one, it's 2 again, and so on. So I'm monitoring some state variable. In this case, it's a property, the length of a props, and I'm updating a different part of the page when that changes. It can be done, and so we can automate some behaviors in our application. When something changes here, something else is triggered, and then may be updated there. But in many cases, it's the complex solution to a simpler problem. Okay, because in our mind we say, okay, when the list changes, I need to update this number. But actually, and it works, okay? Just remember that when you are changing the number, maybe the number will be another dependency for another effect, so another effect could run. So you can create chains of effects that are executed. It works. But probably we could just write this one. So we are recomputing that from the properties every time. Okay, so the idea, I don't need a state. I was creating a state, okay, number, and building some infrastructure to keep this state variable updated, but this state variable was not an independent variable. It was actually a function of existing props and states. So whenever something can be recomputed from props and state, you don't need a second state to store the result. Right? Because otherwise you will creating a second state that will be snapshotting the initial value, and then you have extra work to do to keep that in sync. Whenever a prop changes, then I need to update that. If a value can be recomputed from props and state, it should not be a new state itself. We should recompute it and avoid creating an extra state and then extra work for keeping the state update, because it's not independent. A state variable makes sense if it's independent from the current ones. If its value cannot be derived by the current props and states, and so it's another variable. But if some state is not independent, but can be computed as a dependency of the current ones, it's better not to create it. But in this case, the computation, so let's see, it works in the same way. 2 answers, now they become 1. And now there are 2 again. So before learning about effects, we would have taken this way, normally. Okay? But the issue is that when we learn about effects, we tend to see or to reason in a sequential way. So when this changes, something else needs to be changed. Wait a second. Before creating an asynchronous behavior, let's see if that can be computed synchronously or functionally. And it will be much less. So when I see in a code a lot of effects that just depend on local variables, I'm always asking myself whether this is the right data flow. We are trying to do some data flow which is different from the natural top-down data flow that React suggests. It works, but it's a lot of work. And if you are connecting different states by asynchronous triggers, it's very easy to forget some of them. And so I have some parts that are not updated because we forgot some interaction or some kind of dependency. Okay, so we need to learn how to use effects and learn when not to use them. We'll see another example when not to use an effect later. So actually, it's a very powerful mechanism, but it's often abused. You see sometimes some code around that uses effects when actually there's no need for that. There's one question, of course, that the computer engineer always has in mind. But if I'm recomputing that every time, I'm not wasting performance. In this case, not, of course, but in other cases, it may be true. So if recomputing something involves some computation, so we don't want to repeat the computation every time. But in that case, it makes sense only to recompute it in some specific case. And for that behavior, so limiting the recomputation of something which is computational intensive, there's another hook which is called useMemo, for example, that memorizes the result of a computation. The first time it will do the computation, it will store the result, and will redo the computation only if the arguments change. So there is this need. We recompute everything. If the computation was heavy, let's memorize the result with the useMemo, not with the state. So useMemo will not create a new state, will just create a dependent variable that is updated when needed. So that's the right hook for solving this special case. Okay, so now we are ready to go to the client-server behavior and see, okay, I want to replace this ugly fake question, okay, data. Now I know what I want to do. I want to call the server by calling API when app initially mounts. So with the useEffect, I could create an effect that will run the first time the app is mounted, so that starts out the application that calls the server and stores some data. So it's something like this, like we want to create a, where is the state? Okay, we have some state variables here, and I want to load the list of questions at application startup. So useEffect, and it needs to run something at the beginning. So again, it's a hook that will be run with no dependencies. Okay? What do we do here is we load something from the server, data from the server, and then set questions with the loaded data. Okay, so we need to learn. No, so right now we could already do that by doing this. It's still fake, but it's closer to the truth. So let's pretend that we are loading data from the server. Like this. Okay? So let's make it a bit larger because it's only 3 lines. What we're saying is that, okay, we are faking the loading of the data from the server, and so we are pretending that this data is being loaded. That's what we need to learn yet. Then once this is loaded, we can set the questions. This can be done asynchronously. We are inside the side effect. So when the data is ready, let's apply it. And of course, if the question will be set only when the server data has been loaded, initially, the initial value of the state, of course, is empty. We cannot put anything there. Okay, normally, when the application starts, it doesn't know the data. As soon as it loads, it will go to the server and say, okay, give me the data, and then store these values inside the state. So there will be, the first render of the component will have an empty array here. The second or later render will actually have some data. So right now, if we save it, it should still, it doesn't. So why doesn't it work? Q is undefined where? Question 14. Oh, yes, yes. That's an error because right now, as I said, I'm moving to a version of the application where the data is not known at the beginning, will be discovered later on. So the first render will be with an empty state, and in question.jsx say, okay, but there is no, sorry, let's go to the home page. Okay. I was inside the question, but it doesn't it didn't load it yet. So the issue was that, let me explain. When I loaded this page, question number 1, I was trying to render the component of question number 1. The component of question number 1, question.jsx, receives or assumes that it can extract a question object from the list of questions. So you receive the list of questions, the ID, and it will display the first one. The issue is that the first time this component is rendered, questions is an empty array. So the filter will return an empty array, 0 element will return undefined, so Q is undefined, and we go on. So the mistake is not here, it's above. It's in up, where we are rendering, or we are assuming, where is that? This question display depends on this route. In this route, we are assuming that the questions are already known. which is when the application is correctly loaded. If I start from the home page and I go to question number 1, I get the right results. Why? Because in the first render, I was here. I was not calling the questions component, only the question list. Actually, I'm calling the question list component twice. The first time with an empty list, the second time with the real list. I don't see it because it's very fast. But actually, this component renders twice. The first empty and then with the list. The list questions component behaves fine if its list of questions is empty. So we should always be careful about corner cases. I'm receiving some data. If this list is empty, do I crash or do I do something meaningful? Okay? This is a problem of jumping into an internal page of the website because I remember an old URL while some data are not initialized yet. It's another complex case to handle. If the user behaves correctly, starting from the home page and so on, everything works right. But if some user jumps into a page that is saved as a bookmark, we should ensure that that are loaded before crashing, basically. So something that we are going to care about later on. Having an application that starts from the home page is easier than having an application that may start from any different part of the page. It's a problem which is called hydration in React speech. So how to reload the data before showing. We'll see that when we have actually the server. So let's go back to app and to our initial question. Where is that? Okay, so right now we have an empty state that creates an extra problem because we need to render the components correctly with an empty state. And we know how to update the data loaded later on. What we are still missing is how to load the data from the server. And for that, we need to learn about the fetch function in the JavaScript library. Fetch is a function that allows a client, a browser, to initiate some call to an outside server. So it makes an HTTP request. So we have our component that needs to call an API that is running on some server. Okay? We already have developed the server last week. We know how to get the data, but we don't know the JavaScript code for calling an API. And fetch is the API for doing that, and it always should be used inside an effect, inside some asynchronous behavior. What does fetch do is it starts an HTTP request, and it manages the response with a promise. So it's nice because it's all promise-based. It receives the URL of the resource and maybe the HTTP methods, or get or put. It receives the URL, it receives the body of the request, all the arguments, and so on. So it's the full information of an HTTP request is done as the argument of fetch, and then fetch will start the HTTP request, so the browser actually will start the HTTP request, and the server will return with a response, and this response will be the object, the content of the promise returned by fetch. So this is an example. Fetch returns a promise. So fetch a URL. When we execute the fetch instruction, we are starting an HTTP request to this URL, to this server. The fetch returns a promise. So for example, with then or with await, we should wait until the promise is fulfilled. When the promise is fulfilled, the result, response, is here, or is here as the argument of then. You know, there are two ways of handling promises. Then we can extract the content. So response is the fulfilled value of the fetch result of which is actually contains the HTTP response. And there are methods, of course, for extracting the actual content of the method. Since response is actually a promise, is not a value, all the methods are asynchronous themselves, return promises themselves. Okay, so for example, we have a JSON method that is able to extract the JSON body from an HTTP response. The JSON method returns a promise that will decode the JSON into a JavaScript object. And we say that, in fact, we are returning this JSON promise, and then we are unpacking the data and storing into a state, showing it something. And this is the same here. So both the calling of a fetch and the query of the result of the fetch are always asynchronous behaviors. They always go with promises. Okay? So either then or await to be able to process the data. So actually the response, which is the return value of a fetch, is a promise that contains a response object, and this response object has some properties that can be read immediately when the response is fulfilled. So OK or not checks whether the HTTP code was in the 200 range or in 3, 4, 500 range, which is an error. So we can check OK, yes or no, true or false, to check whether the server gave us an error. Or we could have the status, which is actually the number, 403, 404, for example. We have the headers. If we need the headers of the response, we have them. And the body that can be extracted. Body is not really a string, not yet a string, it's just a stream that we need to be extracted, because the idea is that the headers are available immediately, and the body can be longer, so we don't want to wait until all the body has been downloaded from the network. We have just a stream from which we can read the body, which maybe takes some time to download. But so we can extract and see the content of the response. You see fetch, a given URL, then, and we have response that we can query. The headers is a dictionary, and the other values are just variables. But then what happens when something goes wrong? Okay, okay, things can go wrong on two levels. The first level is some problems at the network level. So the server name is wrong, it doesn't respond, and so on. So there is no, the HTTP call is not possible, doesn't happen. In this case, the promise is rejected. Okay, so we have to catch it. So the catch of a fetch checks the network errors. Another case of errors is when the actual HTTP calls goes through, but the server returns a wrong error code, an error code. So the server is actually involved, and it returns a bad code. In this case, the promise is fulfilled, is not rejected, and we need to check it. So we have always two levels of checking to do. The first level is whether the fetch is successful or not. In this case, we have a catch clause here. Say, OK, there was a problem with fetch.catch. Okay, there was some error, and this is a network error, normally. So there's no data to show because the call wasn't made for some reason. And we have an error message that can display it. If the call is successful, maybe it's still an error, and we see it just by checking the response. The response.ok, that will tell us, okay, the HTTP status code, is it 200 or 34500? And this OK is telling us this. So inside the check of response OK, we have, say, application errors. Inside the catch, we are to manage the network errors that on 2 different levels. Okay? And then there can be some finer errors, like, okay, the result code is 200, but the data contained is wrong, or for some bugs. That can be some, let's say, logical errors at the last level. So making a call is easy. Handling the result, as always, with an input-output operation is a bit of a mess. Okay? So what we want to do is probably to isolate the call of or the handling of this asynchronous call to another function, not to put them directly in the body of a React component. So I wouldn't want to mix here, to have all this kind of code. Sorry, where's the slides? All this kind of code here in the middle of a component. Okay? So we'll put all this code into another file. For example, I call it api.js usually for doing all these API calls. Okay. So the result of a fetch is a promise returning a response object. The arguments of fetch are, of course, the URL and an optional initialization object. It's a set of properties. By default, fetch only does a get request. If we want to change something, so doing a post or a put, or change the content type, or we'll see later on, providing authentication information and something like that, or, for example, in a post, we need to provide a body with the object being posted. We need to provide all this information into this second object. So we have the URL to call, and then an object that contains the further specification of the request. So method will change the methods, headers will provide some extra headers. For example, if I'm sending some JSON packet, I need to provide the content type application.json because remember Express, the JSON middleware in Express expects to see this header to be able to decode the request body. And then the body itself, if I'm doing a post. So normally, if it's a get, I don't need anything special. If it's a post, I need to provide a property object like this. The body of the response, as I said, is it can be read asynchronously, so it can be decoded with a promise. And well, there are some methods that work on the response, but for extracting the body of the response, the two that are more interesting to us are .json, of course, when the response contains a JSON object, or .text when the response only contains some string, if we want just to have it as a string. Just remember that these are functions that are reading a stream, so they can only be called once. Once they call them, the stream is consumed, and so you need to store it immediately. You cannot call it more than once. Okay. So let's move this to another file where we are handling the asynchronous call. So let me create not inside the components, but maybe, sorry, I can create a folder API inside API.js, for example, and I can create a function load questions. And this function will be an asynchronous function. For sure, because we need to call fetch inside, and so we need to return a promise. Export this function. Like this. Okay? Again, let's continue to fake it. I'm trying to clean the app bit by bit by putting all the fake issues as well. So let's, of course, we have to import the question object. It's not difficult to make it work here. And then we can return this. So I'm just pretending to call an API. Go away, please. Since it's async, this return will be a promise, of course, not just this array. So what we could do inside here is to say, okay, we can call API dot load questions. So we need to import API, for example. Import API from here. API.load questions. Let's call that load questions. And then, which is a promise, and then so load question. The then is here. Set question data loaded. Need. So this is the body of go away for the moment. So the data is loaded, and then we need, okay, it's here. So useEffect is a callback that calls, okay. Okay, and then something like that. Sorry, I'm getting lost into the callbacks. So we have a useEffect okay, that sets calls okay, this is an extra part of calls this, and then okay. Okay, so what I'm doing, I'm setting an effect that will run once, and when it runs, it calls load questions. And when load question resolves, now it's immediately because we don't have the fetch yet, with the data loaded, I'm calling the set question with the data load. Okay. So probably source API.js doesn't provide the export name default. Sorry, it's like this. Okay. Okay. Okay, so right now I'm calling dot question as it was an asynchronous function. It returns a promise, and this promise contains the data. And it's also a good way, from the point of view of this component, there's no difference whether the data is fake or is really loaded from the server. Actually, what we could do, what we would play also for debugging in the application, is to return this later, no? To insert some extra delay to see how the application behaves, no? For debugging, for understanding. No? For example, we could say, okay, we will return with these fake answers, but we'll take 1 second to respond. Yeah? Set timeout. One second, and we do this in the callback. So in this case, when we do the application, we find another bug, list questions, in line 37, inside, list questions. Line 37, questions.map, but questions is still undefined. So let's see where question is coming from. Its question is .pro.question or filter. So this component doesn't behave well when the questions state is not so no, sorry, because I'm returning from the callback, I'm not returning from load question, so I'm returning an empty. So let's do it another time. I should have made this into a normal promise and say resolve this instead of making a return. So let's make it another time. Okay, so now the application is working as soon as these fake questions are returned. What we need to do here is replace this fake operation with a fetch. We want to fetch the actual list of questions from the server. We already have a server which was implemented weeks ago, and this server already contains, go back with the memory, API questions. So what we should do right now is just to run the server, because right now it's sitting there. We need to run the server in parallel to the client, and let the client do this call. And pass the JSON result and just return this JSON result. It's not so easy because, as always, there's an extra problem, which is the permission to call an extra server from the JavaScript, but it's something that we are postponing until after the break. Okay? So right now we have everything in place. We are just focused on how to do the fetch inside the React component. So I will pause here for a while, and so we come back. When we come back, we'll say actually move this call and run the two servers at the same time.